Good morning, class. So, in today's botany lecture, we are going to see some famous botanical classification. Actually, we already studied about the taxonomy and how we can objectify the taxonomy, like why we need taxonomy. And this part we already done in our previous lectures. So now we have to see what kind or what are some famous botanical classification among from the history to today's world. So, before begin with these all famous kind of classification pattern, the thing which we have to remember is like the these classification that was contribute, or you can say we classify them. These classification also classify them. Uh, Classifying them was in a three manner. Like the first type of the classification, the idea of classification that was come in to the Theophilus is like 300 before Christ, and this whole phenomena he put it into a manner of artificial classification. So at that time we had the artificial classification system. After some scientists introduced the system of classification on the basis of natural phenomena. So then the natural phenomena has to become in discipline, and after that the major and important kind of classification, that is phylogenetic classification. So basically, we are having these three broad categories of classification. The very first kind of classification that has been introduced, that was the artificial classification system, and the second type is like you can say natural kind of classification, and third is a phylogenetic classification. So we will going to see one by one, like from the artificial classification system, we are going to see the Carlos Lianas, the modern scientist father, or you can say father of modern botany. And after that, in the natural classification system, we are going to see the Bentham and Hooker's classification, and in the last one, in the phylogenetic, there will be the Cronquist, Arthur, Cronquist. Their classification system we are going to see. So these were, you can say, they were the botanists who really played a very important role in whole classifying the plant unit into the several important parameters. So now we will begin with the Carlos Lian system of plant classification. So his classification of system, the Carlos Lianas. So basically, we will skip the whole name. We will be calling them the Lianas system of classification. The system of classification that was an artificial sexual system. So artificial means not everything that has been introduced in that system that was not natural. That some of the part was based on assumptions, and some of the part was imaginary. So that's why this system we can call them the artificial kind of system. But Lianas really take a very important point in their artificial system. That was the sexual system in the plant. So what he did, he classified the plant on the basis of their sexual pattern, or you can say how they sexually produce. So their reproduction, that was the main concern of the Liana system of classification. So now in the sexual system, what we have been taken, so it's based solely on the number and arrangement of the reproductive organs. So okay, so that is the very important thing to be quantified in the classification. That is based on the number and arrangement of reproductive organs. So plant's class was determined by its stamen. So how he can classify the plant class, like when we do the taxonomic units, like order, genus, class, or division, phylum. So basically, when he was dividing the classes, so he divided the class on the basis of number of the stem. So stamen, you all know the stamen is the male part of the female flower. So how much number of the stamens will be present in a flower. On the basis of that, he is classified them among the groups. So, and it's ordered by its pedestal. So the class was determined by their stamen numbers and their order. Another taxonomic unit that was, classified by on the basis of number of its pistil, the female order. However, resulted in many groups that seemed unnatural. So basically, that was artificial. So how it can be look like natural? But yes, they were having even a very, very important turning point in the whole history of the classification. So actually, this were a major turning point. Why? Why we are calling it the major turning point? Because that was a very important step considering reproduction inside the classification. So even till today's time, or in modern today's classification, we consider that point as an important point. So, for example, the order Mon Adifil under the class Monacea and include plant with separate male and female flower on the same plant and with multiple male organs joined onto a common base. So, like he describe a order, the order that is named as Moon Adifia. So this order under the class Monarchia. So basically, this characteristic of this class was included that they are having the unisexual flower, separate male and female flower. And the terms here, the same plant, they will be presenting on the same plant, but the condition of male flower that they will be present in a multiple form, but their bases are joint. Okay, their joint base filament, like if we are talking about a stamen. So stamen have these two parts, one the anther and the filament. If we call them the joint, means not the stamen, the wholly joint. Maybe sometime their filament can be joined, maybe sometime their lobe anther that can be joined. So that depend on what kind of joint is present in between. So this order also include conifers such as pines, firs, cypress, but also few true flowering plants such as castorals. How can we imagine that we just merge a flowering plant into the gymnospermic plant like pines, firs, and cypress? So that was not true, or you can say that was not a real kind of classification that can be followed. So, but that was the idea. That was the first thing that someone gave that whole scenario. So that's why they possess an important role in our history of classification. Plants without obvious sex organs were classified in the class Cryptogamia, or plants with a hidden marriage. So basically, the plant where sex organs. This is an important term even in today's world of, or in today's time. We are using this term cryptogams for classifying the plant. So that important term was come from Lianas, that the plants without obvious sex organs were classified in the class Cryptogamia. Means the reproductive organs is hidden; they cannot be seen on the surface. So if they cannot be seen, they will be called as a hidden plant. So which lumped together with alga, lichen, fungi, mosses, other bryophytes and ferns. So, but these are the plant that covered, or you can say lumped together with the other things like the alga, lichens, fungi, and mosses and bryophytes and ferns. They all considered as a cryptogamy. That was like a 70% true thing. Only 30% can be a misreading, but yes, 70% Linus was right about it. Now, Gyan thus attached great significance to the plant sexual reproduction and divide plant into 24 classes. So, on the basis of their whole point of view about the reproduction, he classified the whole plant's classification into 24 classes, mainly on the basis of the number, union, and length of stem. So, the main focus was on the basis of number, how many numbers of stamen will be present, and their union, are they connected or they're separated, or the length of the stamen and what is the length. That is also a important point in the whole phenomena of classification by Linus. Linus was also the first person to use the binomial system of nomenclature, and that is why Linus is famous, because he gave us the very perfect thing inside the classification, that is called the nomenclature. And even if we correct it, that is binomial nomenclature. So, for him, species of organism were real entities, which could be grouped into the higher categories called the genera. So, whole this genus phenomena that was given by the Linnaeus, because he believed that these related species, they has to be put in a higher authority or higher category, or they are related with the higher category. So he had this in this mind, that there is some taxonomic unit which is going to cover some same kind of species under that. So that's why he put the name genus, and the same kind of species which are having the same kind of phenotypic features, they just have been put in those genus. Part of the Linnaeus innovation was the grouping of genus into higher taxa. Those were also based on shared similarity. Where after that, when we have some genus, like one genus, two genus, three genus, now based in on the similarity between the genus, they needed to be put somewhere else. So now the term come in the consideration, that is called the order. Order into classes and classes into kingdom. So basically, a phenomena was not in the descending order; it was always in the ascending order. First, they got the species. They think how we put them into what place. Then they see the whole similarity level between the species. Then they put into the genus. Then we got a genus, and they seen that the several genus have similar kind of features. So they put them into the order. After that, they say the several orders have some level of similarity in it, between them. They put them into the classes, and after the classes into the kingdom. So this is the whole, whole process in the ascending order to make from the species to the kingdom. Earlier, he believed that the species was not only real but unchangeable, and this is also a very important fact. He said the species not only real but is unchangeable. Okay, we cannot change it. They have their own individual unit which we cannot alter. But after observing how different species of plant might hybridize to give rise to new species, he abandoned the concept that species were fixed and invariable. But when he see that hybridization process and cross pollination will make a species having the two characteristic in them, so basically, then he give us a phenomena that is that they are not fixed, species are not fixed, but clearly in today's world, species are a fixed individual organism. If they do hybridization, that does also happen in a close related species most of the time. So that not give a very large diversity inside them. So basically, the some of the feature can be altered, but not all. So, and suggested that some, perhaps most species in a genus might have arisen after the creation of the world through hybridization. So he give this phenomena after he think that the species can be not be fixed and it cannot be invariable. So he give the thought that all the species present inside the genus, that are the result of the hybridization process. They are not individual intact unit. So basically, this all come from the hybridization, or they all are the hybrid, not a fixed invariable units. Now we will be seeing some merits of Liana's system of classification. So the only merit of Liana's system of lies in the fact that it aids in the quick and easy identification by means of one of your character. So basically, in this classification pattern, you don't have to go in very deep. Just after seeing them, just after seeing one or two character, you are going to identify it. By having very few character. You don't need many much character. Demerits of Liana's system of classification. So since this system is based on different rather than the similarity of the sex organ, Very often, closely related plants have been placed in widely separated groups. So basically, the he thought that whatever the things he was seeing and similarities and placing them in a specific Texas, but that was not enough because most of the parameters in them they do not much similar. So that's why whatever the species he thought and put them into the closely related plant, they actually have to be placed in a widely separated group. And what he was thinking the similar thing, they were actually very quite different from each other. So this is kind of mismatch that has been done by Lianas because that was a learning phase. We cannot call it as like a demerits, but yeah, they were not as efficient. But that was a starting point of something, and we know that nothing can be perfect in a one day. We need to practice. We need more evidence. We need more digging. We need more work to perform for having a final, last, and good product. So that's why these things Lianas did, but he initiated that was a very practical. Affinities and relationship among the taxa have not been considered. So basically, the affinity section and relationship among the taxa that not being considered in the Lianas system. There is no distinction between the dicot and monocot have been mixed up and put together. So if we see another pattern or another parameter that is about the dicotyledon and monocotyledon. So based on dicotyledon and monocotyledon, we divide the angiosperm requirements. So, but he didn't do that. The placement of gymnosperm in class 14, Titaniumia, along with the angiosperm family Libete is the most unsatisfactory. He did blunder also, like he put the gymnospermic family along with the angiospermic family, and that cannot be happen inside the classification. That you cannot go or merge that kind of relationship among the angiosperm and gymnosperm family. So this is all about artificial kind of system of Lianas. Now we will be going to see the Bantam and Hooker system of plant classification that was come under the natural system of classification that was second in the let's say this is the second in the developmental phase. We will going be to see the what are the merits and demerits of Bantam and Hooker system of classification. So here, Bentham and Hooker system is the first great natural system of plant classification, and that is a very important. So the system of classification they gave that was the first natural system that was widely accepted. Though this system is not very natural, yet it is very easily workable and is important from the point of view of its field application. Maybe that do not have all the feature of natural system, but whatever the work he has been done in here, that based on the field application, not any kind of imagination. Whatever the classification they have been made, they made on its application that is already can be done. So the system has been worked out as a result of very careful comparative observation of all known genus of phanerogams and not copied from other available literature. So actually this is also a very good point of Bentham and Hooker. Then they didn't copy it from anywhere else. They just do a very careful comparative observation. They did it by all themselves. They did the research. They did not just review it from somewhere and write it down. They did the original research and whatever their findings, they placed them into their classification system. It was accepted by the English, British, and by USA and other European countries. So the thing which they have been given that was widely accepted throughout the world. Greater emphasis has been laid on the contrast between free and united petals in the system. Like the example of dicotyledon is divided into three subclasses: polypetalae, gamopetalae, and monoclinidae. So the great emphasis, like basically, they give a classification which parameter was a free and united petal, and still we are using them inside the angiosperm. the classification based on free and united petals. So free petals, we talk about the polypetalae, fused petals, gamopetalae, and no petal at all. That can be monotypic. Next, a special feature of the system is the addition of this flora or a totally new arrangement of dividing certain groups on the basis of aquatic and terrestrial characteristic of the plant. So this is also important. Like they give all the new parameter here that just do the classification in the addition of the aquatic and terrestrial characteristic. Like they showed what kind of adaptation can be taken by the aquatic and what kind of characteristic can be taken by the terrestrial plant. In this system, the monocots are divided from dicots, and in the class monocotyledon are important is given to the relative position of ovary and parent characteristic. So, as Lianis just mixed all the monocot and dicot and placed them into a one manner, but here Bentham and Hooker, they didn't do that mistake again. They just made it clear that dicotyledons and monocotyledons. They should be present in a separate version. They cannot be present in a same area. So that's why this is also very important entities from them. And the monocotyledon, they give them importance because of their relative position of ovary and parent characteristic. Their ovary and parent characteristic, they just classify them like some unique. Now, demerits of Bentham and Hooker system of classification, if we see, so this system does not indicate phylogenetic relationship among different taxa of plants. So, phylogenetic relationship that has not been seen in the Bentham and Hooker system of classification. That's why we need a different kind of classification in a modern world, which involve phylogenetic relationship. The position of gymnosperm between dicot and monocot is only for the sake of convenience rather than indication of affinities. And here, the position of gymnosperm, which has been placed in between the dicot and monocot, they just like place this for like they find it convenient, but they didn't give a very very much good explanation about it, like why we place that there. So that's why this is a foremost demerit. The system is based mainly on single and mostly artificial, mainly single and mostly artificial mean morphological character, with the result that many closely related family are widely separated from each other and have been placed under different orders. Similarly, unrelated family have been grouped together. So the same thing which has been done with the Liana system of classification. Some of the errors that also repeated in Bentham and Hooker system, that they also did the same thing like placing the species which really do not have so much similarity in between them as between the others. Here are some more demerits. The position of the Orchidaceae. Okay, so the position of the Orchidaceae and Schiminaceae at the beginning of monocots is not satisfactory as Orchidaceae is an advanced family, and in this system it has been considered primitive and placed at the beginning. Now this Orchidaceae that placed in a very beginning of the monopod, that was not good, because if we see the characteristic feature of Orchidaceae, they are developed features. So you cannot just put anything developed in a very primitive phase. You have to put in last, or you have to put in an evolved version, but they put it in the beginning. So that was also utmost demerit. In monocots, much stress is laid on relative position of ovary and parent characteristic in determining the affinities, which is unnatural and unphylogenetic. So actually in monocot, they talk about the position of ovary and parent, and based on that, they determining the affinities. But that was not true at all, and that is not true at all in present situation scenario also. That they cannot determine affinities just on the base of their positions or just on the position of ovary and parent. That is not even related because if we wanted to see the affinities, we needed to see much more characteristic for the not just the characteristic or position of ovary and period. They do not have even have a major role to play in the sexual behavior. The origin of angiosperm is not clear. The origin pattern, what the origin they give about the angiosperm, that was not also clear in their system of classification. Third one, the phylogenetic classification that was given by Arthur Cronquist. He lived from 1990 to 1992, quite a nine in his life. Now, the botanist Arthur Cronquist. He was a senior curator of New York Botanical Garden and adjunct professor of Columbia University. So, New York Botanical Garden, they also have a very wide or diverse range of plant inside them. They also have very famous herbaria with them. So, the Arthur Cronquist, majorly they have a control of over a lot of the species can be seen by him. So he presented an elaborate interpretation of his concept of classification in the evolution and the classification of flowering plants. So the whole of his work that was based on the classification, he wrote a book. The first book in the 1968. In that book, he talked about the evolution and classification of flowering plants. The further addition of this classification that was published in an integrated system of classification of flowering plants in 1981. After that, he wrote another book that is based on the integrated system and classification of flowering plant that was published in 1981. The latest revision was published in second edition in 1988, The Evolution and Classification of Flowering Plant, and it discusses a wide range of characteristics important to phylogenetic system. So basically, he gives us a scenario in which we can work on the phylogenetic relationship over a time period. Every species they have similarity in between them, or they also have differences in between them. But what degree of similarity we are calculating here, that is important. Because just watching or seeing some like three or four characteristics, you cannot analyze anything. You needed to be know a whole concept about based on all the parameters. Then only you can find something that is accurate. So basically, he give the many characteristic feature, many characters, many basics to plan a taxonomic unit. So he also provide synoptic keys designed to bring the taxa in appropriate alignment. Basically, he gave us keys that on the basis of that we can place a taxa in appropriate alignment. He also represented his classification in charts to show the relationship in the order within the various subclasses. And his system is more or less parallel to the Tattajan system but differ in details. So Tattajan, the same time of scientist, he also worked on the classification and his system of classification also has some unique things, but their details were different. So like we will going to see the following principle that was adopted by Cronquist to classifying the flowering plants. So the very first principle here, the earliest angiosperm were shrubs that rather than trees. So he tell that the very primitive kind of angiosperm, most of them were the shrubs. They were not the tree. They were not the big tree. They were like the small and modified leaves tree or modified shrubs which have do not have a very wide canopy and anything. So the simple leaf is primitive than the compound leaf. Second thing we postulate that the simple leaf is primitive and simple leaf comes first and primitive leaf and the compound leaf that comes later. Or you can say compound leaf is modern. Reticulate connection is primitive than parallel connection. So reticulate connection we see the cycle variation that is parallel connection. Parasites of this matter is primitive than other types. lot of type of stomata. I told you in a stomatic critical lecture about the asystematic, parasystematic, diasystematic. So they are kind of the stomata are present. So he told that parasystematic stomata is older. Cylinder, elongated, long tracheids, and numerous scleriform pects are primitive. And further specialization leads to the shorter, broad vessel with somewhat thinner wall and transverse end wall with few larger perforation. That is new. So he just digging on the vessel formation. What kind of vessel formed primitive and what kind of vessel formed later. Long and cylinder sieve element with the oblique end walls where the sieve area is scattered along the longitudinal wall with a group of minute pores are primitive. So this is a condition about the sieve elements where they have this longitudinal wall with the minute pore that is the primitive, whereas a phloem with short sieve tube element where end wall have a single transverse sieve plate with large opening is derived condition that is new. The area and activity of cambion and also a length of fusiform initial is important in primitive with form which must gradually become reduced in the advanced one. So we tell about the activity of cambium also with the length of the fusiform initial. That was more in the primitive form, but in today's plant that has been reduced. Plants with vascular bundle arranged in a ring is primitive rather than scattered. They are found in monocots. So basically, the ring formation of the vascular bundle that was the ancient or that was primitive, and the scattering of vascular bundle they do not present in a special manner, just scattered inside the body, scattered inside the cortex. That is a new thing, and these kind of bundles are found in the monocots. Plants with large and terminal flower are primitive. So he tells that if the plant having the large and terminal flower, they will be primitive. And those many arranged in monarchia and diarchia type of inflorescence, they have been derived from these types. So he just said that the inflorescence that arrive from the single or terminal flower. Single and terminal flower come first and inflorescence come later. Flower with many large, free and spirally arranged petals, many linear and spirally arranged stamen, and free carpel are found in Mangroveaceae are primitive. So this kind of condition inside the petal formation and carpel that is primitive, and other types like the reduction, aggregation, elaboration, differentiation, this is the new one. Plants with unisexual flower are evolved from bisexual floral ancestors. So the bisexual flower that are the old one, that are the primitive one, and the unisexual flowers they are arised from the bisexual floral ancestors. The large and the indefinite number of floral members are primitive, then the small and definite number. So basically, if the very large quantity and indefinite number are present inside a plant body, that is the primitive kind. But the definite and the small number of flower bodies is a, we can say, is that is a modern character. We talk about androecium with many stamens primitive than the reduced number. So if we are having the androecium with so many stamens, that has to be primitive, and with reduced number that is modern. Radial stamen with embedded pollen sac is found in some Manglonian genera. They are considered more primitive than the others, and uni-aperture pollen grains are considered as primitive, and the trap-tailed type of the derived from this. So, uni-aperture pollen grain means one aperture of the pollen grain. They can be considered as a primitive, but the tri-aperture they can be considered as a modern. Insect pollinated plants are considered as a primitive from which when pollination plants got evolved. So insect pollinating plant. means where the pollination has to be done by the insect, they can be considered as primitive. But if the pollination has been done by the wind, so that is the feature that has been evolved. Desired presentation is primitive. Okay. And the anatropis of dual is primitive than other. I'm just telling you what is primitive as by the Arthur Columbus, what he thought was primitive, and the second thing in this line that will be derived from the primitive. Ovule with two integument, like the pi technique, which ovule which are having two integuments, that is primitive, and other one they are just unitechnic condition, they are evolved. Embryo with 8 nuclei is primitive, and embryo with 4 nuclei has been derived. Okay, so 8 cell nuclei that is common and primitive. Monocots have been developed from dicots through abortion of one cotyledon, and also he said dicotyledon was primitive, but the monocotyledon developed from the dicotyledon by after aborting one cotyledon. The follicle fruit is considered as primitive, and further dry dehiscent fruit is more primitive than fleshy and indehiscent fruit. So he said that the fruit which are dry fruits, they are primitive than the fleshy fruits. Now, what are the merits of his system and classification? This is general agreement of Cronquist system that one of the other contemporary system like Tafkajan, Dandin and so on. So that is like in cooperation with all these classifications, so that is good. And all other people also justify his way of his classification. Detailed information on anatomy, ultrastructure, phytochemistry, chromosome, beside morphology. So he didn't just talk about the morphology. He also talked about the every feature which is based on the anatomy, internal structure, ultrastructure, outer apical structure, phytochemistry, the chemistry of the plants, and their chromosomes. So all the major parameters has been considered in the Arthur Cronquist classification. He also gave the revised classification in 1918. So he just not gave the classification once and rested out. He did the whole research and again to find something new. The system is highly phylogenetic. So highly phylogenetic, that was a type of the classification in which we are studying the Arthur and Cruscus. That phylogenetic means similarity between the divisions that is very high. Nomenclature is accordance with the ICBN. So there is a nomenclature that has been used here, that is the ICBN nomenclature, International Code for Botanical Nomenclature. The family Asteraceae dicot and Orchidaceae monocot are generally regarded as advanced and rightly placed toward the end of respective group. So the mistake that has been done by the Bentham and Hooker, placing Orchidaceae in the very present level in the monocot, he correct their mistake and place it at the right his position and right in position. The relationship of different taxa has been described with diagram which provide valuable information. The family Venturaceae, he placed it right beginning of the dicot, that was also good. Subclass Mangulaceae, he considered is like the most primitive group of dicot and placed in the end of the monocot and starting of the dicot. As a text in English, the system has been readily adopted in different. So basically, this system of classification was adopted and attained by many others who was working on the phenomena of classification at that time. Now, demerits, not everything was so right about Cronquist. There are also some demerits also. So, what was demerits? Highly phylogenetic and popular in USA, this system is not useful for identification and adaptation in herbaria since intended key for genres are not provided. Means key features. they should be provided. Like every genus have some special characteristic. But in this characteristic, in this classification, he did not provide the identifying features of a specific genus. So that's why we cannot use it in the Herbaria classification. Delgum and Throne treated angiosperm in the rank of class and not that of a division. So the class division cannot be just for the angiosperm. There's something more which we need. Superorder as a rank above order has not been recognized here. So no order, no class, no rank has been given above the order. So though it is represented in other contemporary classification like Taktajan, all other one they give the highest ranking in their classification, but Chronicles didn't do that. Okay, so Atherfold pointed out that the subclass MLDs does not represent ancient signed branch of subclass Mangolidae, but is remnant of transition from Mangolidae to the Tailidae, Rosedae, and Astridae. So some have pointed that special class of Hamelidae they did not represent as an ancient site. There is a different in opinion with other authors regarding the systematic position of some order like Diphylae, Adelae, and Euclid. So these order were being distributed. You can dispute it over the time by the scientists. They tell that they should be placed at their specific position. So this was all about all the three kind of famous classification we seen here: artificial classification, natural classification, and also the phylogenetic classification. This is all about today's class. These are some references by which you can also see some more about how you can going to see the classification of famous scientists. Thank you for today's class.